I'll start in 5 minutes. Yeah, but the hope my screen is visible. So today, I'll just give a quick walkthrough over the KNN model and the logistic regression model that we discussed about yesterday. And so, as usual, we'll start by importing some packages. Okay, and so the first thing, sorry, uh, okay, the first thing that we import is called make classification function. Since we don't have any sort of like we don't deal with any real life data sets now. Okay, we'll be dealing with it in your project phase or somewhere when you're teaching advanced data pre-processing and those stuff. We'll come to that later. But to demonstrate a toy example, we'll start with the synthetic data set. Okay, and that's where the make classification function helps. Then you all know about the train test split function that will help you split the data into training and test set. You have the K neighbors classifier from scikit-learn. This is where your model is. Okay. Then some plotting functions. You have the logistic regression model. NumPy, you know, uh, you use it to do some mathematical operations. You have CBON, and you have a bunch of different metrics from scikit-learn. Okay. Uh, so I start by generating a binary classification data set. Okay. Can anyone tell me uh, what's the shape of X and what's the shape of Y? Anyone? Just look at this and tell me what's the shape of X, what's the shape of Y. Anyone? Just read these arguments, you'll get an idea. Tell me what's the number of samples and what's the number of features. I think I'm audible. No. Okay, the shape will be 1000 in the first.
1000 + 2.
Yeah, it's a 1000 cross 2 matrix. Yeah. Shape of Y will be 1000 cross 1. It's a binary classification, so it will just be zeros and ones. Okay. And once you have the data set, okay, X and Y, X are your features, Y are your labels, you split the data into training and test sets. Okay. That's where you use the train test split function. You pass your X data, you pass your Y data, and you mentioned test size. Test size is zero point 0.2 means 20% of your data set will be in the test set. Okay. You have X train, X test, Y train, Y test. Now I'll run this and I will plot the data set. Let's see how does it look. This is how my data set is. Okay. and I have a test point. Okay, as you can see here. Here, this is my test point, and I want to use k nearest neighbors. Just by looking at it, okay, what do you think the class of this test point is? Is it class 0 or is it class 1?
Class 0, sir.
Yeah, since most of the points are situated, the class 0 points are more closer than the class 1 points. Okay, so what we'll do, as I said, we need to try different k values. Okay, these are your neighbors. The neighbors meaning the value for k. What you can do is for k in neighbors, okay, you are going through this list. The list will have values from 1 to 9. Okay, what you do, you initialize this k neighbors class. Okay, you put in neighbors as k. So as this loop goes on, it will try 1, 2, 3, 4, 5, 6, 7, 8, 9. It will all try all these things. It will, if you call knn.fit on the train data set only, okay, you should not call fit on the test data set. Okay. Once you do that, you have the model ready, you have the trained model. Now you need to get predictions on the test set. For that, you use the predict function on the test set, okay, and you get your predictions, that is ypred. Then you can calculate accuracy using the accuracy score function. Okay, do that. Then you have y-test, ypred. First, you pass the label, that is y-test. Then you pass the predictions, that is ypred. Okay. Once that is done, you also store the accuracy. Okay. And what you do, instead of accuracy, you can also have the error. Like 1 minus accuracy is the error. Okay. And what your job is to identify what is the best k value. Okay. I'll plot it. Now tell me what's the best k value from this graph. Tell me. This is error. So lower the value, better it is. Okay. So tell me what's the optimal value for k?
8, sir.
Why 8?
It is have lowest value, and 3 also have the
Yeah.
lowest values.
So yeah, I think the answer should be 3 because as you keep increasing number of neighbors, okay, what will happen is you need to do more number of computations. That will be costly. So you need to find a trade-off. And 3 is it's good. It has lower error, and you don't need to do much computations also. Okay. So 3 is the optimal number of neighbors. Okay, this is done. Similar case, you have the logistic regression model also. Okay, you define the model, train it, test, calculate score, and then we'll see how it is. This is what the logistic regression model has learned. Do you think this model is good? And also, while calculating accuracy, you should only do it on the test set, okay, not on the train set. You should remember that. Do you think this model is good? What's the accuracy? As shown, it's 88%. Do you think the model is good? Can it be improved? Can it be improved?
Yes, a slight improvement because class 1 are merged with class 0.
So this model, it will only always give you a line like this. There are better models that you can use, like neural networks or random forest decision trees and so on. That will I'll be taking it in the coming classes. But for now, this is good enough. 88% is good enough, not very bad. If it's above 50, you can say that it's better than a random classifier. Okay, that is done. let's compare the logistic regression prediction and KNN prediction. Okay, let's see how it is. This is the confusion matrix. Okay, as I described before, you have the actual label here, the predicted ones. Based on the confusion matrix, which do you think is better? Is the KNN better or the logistic regression better? These are true negatives. These are true positives.
Logistic regression.
KNN, sir.
Yeah, it's KNN because you have more number of true negatives and true positives. Okay, you should always look at the diagram, main diagram. And I mean, logistic regression can be improved. You can play around with hyperparameters and so on. So, can someone calculate the accuracy for KNN from this matrix? Accuracy. I have, yeah, I think I told the formula. It should be true positive plus true negative divided by true positive plus true negative plus false positive plus false negative. Okay. Just tell me what's the accuracy for KNN.
Sir, 0.95.
Yeah, 0.95 is correct. And you can also calculate precision and recall, like precision score for KNN and logistic regression. Same recall for KNN and logistic regression. This is already calculated. Okay, it's already good. You have high precision for both the models. You have higher precision recall for both the models. Then you can also calculate the ROC AUC metric. And this is how you calculate. You have the ROC curve. And for this, you need to predict the probability. You can't put in the just you need to use predict proba instead of just predict. Okay, and this is how the curve looks like. So KNN has more area under the curve. AUC means area under the curve. Okay, and it's better than this dotted blue line. This dotted blue line means it's a random classifier. It's better than that, and KNN both have almost same area. Nothing much different about it. So you can go ahead with either KNN or logistic regression. Okay? And these are all plotting things that I think Ruturaj must have taught you in previous classes. Okay? So this is all there. What I want you all to do, I'll share this notebook now. Just a minute. Put it in the chat. I think you all know how to run this collab notebook. Okay, so start with this collab notebook. What I want you all to do is instead of 1,000 samples and 2 features, okay, try these models for 2000 samples and 4 features. Okay, 2000 samples, 4 features. Keep n informative as 2 and n redundant as 2. Okay. Informative and redundant features. Okay, to explain those concepts, maybe when it comes to random forest and feature importance, I'll discuss the concepts there. But I want you all to change this data set. See how the data set is. Try KNN for, let's say, the neighbor should be 1 and 1 to 20. Okay. And tell me what's the optimal number of neighbors. Similarly, for logistic regression, what I want you all to do is maybe change the value of C. Okay, there is a parameter C. Okay, C is 1. That's the default value. But I want, similar to KNN, I want you all to try different values for C. If C list equal to, let's say, 0 0.1, 0 0.01, 0.001, 1, and yeah, try these 4 values and tell me which C value is best. Tell me which K value is best, and also what's the accuracy of both these models. Okay. This is the task for today. If you have any doubts, you can ask me. I'll be here online to clear any confusions. But I would suggest everyone run the code, try changing things, see how everything is working. Like here, instead of accuracy score, you can calculate precision or recall. Just play around with the code. If you face any difficulties, let me know. I hope everyone is able to access the notebook.
Yes, sir. Sir, in this section, what we change, the K value will change, sir.
Can anyone tell me what's the best K value?
Sir, I got a neighbor as 8, optimal neighbor as 8, sir.
Okay, good. Did you try from 1 to 20?
Yes, sir, 1 to 30, I got 8.
Okay, yeah, that's correct. That's good. Now, logistic regression. Try the C values.
Okay, sir. So for C value 0.01,
Okay, yeah, that's correct. 0.01. What's the accuracy?
so the test point will placed on the -3, 0 and -1 between the test points.
No, no, accuracy score.
Yes.
Like here it's 0.88. Like for 0.01, what's the accuracy?
0.94, sir.
Okay, yeah, good. Same, can you calculate uh, the precision and recall also for the best model?
No, sir, I know time.
No. Okay. Yeah.
Sir, I got the precision as 0.96, sir.
Okay, then recall.
Sir, 0.928, sir.
Okay. This is for KNN or logistic regression?
Sir, for KNN, sir.
Okay. For logistic regression, what's the precision and recall?
So 0.86 as precision, 0.83
Mhm.
for recall, sir.
Okay. Then ROC curve, I think you all can plot. That's not an issue. So
Yes, sir.
yeah. Okay. So I think if you are able, if everyone is able to run it, that's good. And like you should remember, like this is how your project also will be. They'll give you a data set, ask you to try different models, calculate different metrics, and that's how it's going to be. So as these notebooks keep coming, try to uh, run it cell by cell, check how the data is, what model you should use, and so on. Yeah. And I think if you all are done with it, that's it for today's class. We'll see on Monday. Okay, Monday we'll start with naive base classifier and supported permissions. Okay,
Okay, sir.
yeah, thanks. Yeah, if there are no doubts, we can end the session. Thanks.
Sir,
Yeah,
sir, the data set will already you said that is synthetic data set.
yes.
Sir, how the data set will be loaded in this? Can you explain?
Mm, Here it will be randomly generated. Uh, it will be randomly sampled from a Gaussian normal distribution, I mean Gaussian distribution. So, I mean, you don't need to worry about how this data set is generated for now.
Okay, sir.
Uh, so, uh, it's you will get random points with some separation and all those things.
Okay, sir.
Yeah. Okay. No more doubts. Okay. Then, thank you for joining. Enjoy your weekend. We'll see you on Monday.
Thank you.
Yes.